Exercise 7.2, Problem 15, Discussion. The angles of elevation of an artificial Earth satellite is measured from two Earth stations situated on the same side of the satellite are found to be 30 degrees and 60 degrees. The two Earth stations and the satellite are in the same vertical plane. If the distance between the Earth station is 4000 kilometers, find the distance between the satellite and the Earth. Root 3 is 1.732. Okay, so there is an Earth satellite which is sitting in the sky, right? And the angle of elevation from an Earth station is 30 degrees and 60 degrees, and the distance between the Earth stations is 4000 kilometers. Okay, now we are asked to find the distance between the satellite and the Earth. Okay, so let's draw a simple diagram. So A and B are the two Earth stations, and D is a satellite. Okay, and they are in the same vertical plane, which means you can draw a simple figure like this. It means to say it is on the same plane. Okay, I'll explain it a little later. Okay, now this is 30 degrees and this is 60 degrees. So A is an Earth station, B is an Earth station, and D is the satellite. The distance between the Earth station, that is AB, is 4000 kilometers. Now we are asked to find the distance between the satellite and the Earth. Okay, so this is the distance. That basically the height. Okay, that's all it is. Now we have two triangles, A, C, and D. Okay, and the other one is B, C, and D. Right? So tan 30 will get us CD by adjacent, that is CD by AC, and you know tan 30 value, which means AC you can write it in terms of CD. Similarly, using tan 60 is CD by BC, you can write BC in terms of CD. So you are getting CD in terms of AC and you are getting CD in terms of BC, and you can equate those two equations as we did in the previous problem. So you will get a relationship between AC and BC. And again, you have one more relationship, that is AB plus BC equal to AC, right? That is in the straight line, you can see it. We know AB is 4000 kilometers. So 4000 plus BC will be equal to AC. You have one more relationship between AB, BC and AC. Using those two equations, you will be able to calculate CD. So this is how this problem needs to be done. Very similar to the previous problem. So let's list what is given in the problem. The angle of elevation is given, that is 30 degrees and 60 degrees. Next, the distance between Earth station is given, that is AB is 4000 kilometers. Right? We need to calculate distance between the satellite and the Earth. That is, we need to calculate the height basically. That is CD we need to calculate. And the same formula, tan theta is opposite by adjacent, because we have some value on this side and we need to calculate this. So this a relationship which connects the unknown to the known is tan theta. That is, we have to have a relationship between opposite and adjacent, that is tan. Okay, tan theta you can use, and we also know AC equal to AB plus BC. Right? Now, first step, as usual, draw a rough diagram, label and mark the diagram with the given values. Step 2, in triangle ACD, substitute the value of theta, that is theta is 30 degrees, in tan theta equal to opposite by adjacent, that is CD by AC. Okay, tan 30 is CD by AC, and get CD in terms of AC. Get CD in terms of AC. You might get tan 30 is 1 by root 3. So 1 by root 3 will be CD by AC. Using that relationship, using that equation, get a relationship between AC and CD, or write CD in terms of AC. That's what it's meant here. Now, next, do the same process for triangle B, C and D, right? And get CD in terms of BC. That is, tan 60 is CD by BC, and get CD in terms of BC. Right? Now you got CD in terms of BC in equation 2, and you got CD in terms of AC from equation 1. Equate that CD from both equation 1 and 2. Okay, you will get a relationship between AC and BC. Okay, next you see there's one more relationship, AB plus BC equal to AC. Okay, and we know AB equal to 4000. So you will get a relationship between AC and BC. So using these two, we will be able to solve and get the value of CD. Okay, so what I suggest is pause the video here and try to work this problem on your own. It is very similar to the previous problem. If you are having any difficulty, please come back and check here. Go through the video and work it out. And if you have done, please come back and check your working against our solution. A solution. So let A, B, D be the location of the two Earth stations and a satellite respectively. A is one satellite station, B is another satellite station, and D is the satellite. Okay, and they have given us the angle of elevation is 30 degrees, that is angle DAC is 30 degrees, D, B and C is 60 degrees. Now consider this triangle A, C and D. Okay, that will be, in this case tan 30 will be opposite by adjacent, that is CD by AC. So you will get tan 30 is 1 by root 3 or CD by AC equal to 1 by root 3 or CD will be equal to AC by root 3. And AC by root 3, you can multiply both the numerator and denominator by root 3. You will get root 3 AC by 3 or CD equal to root 3 AC by 3. This is the relationship between CD and AC. Now do the same thing for the triangle B, C and D. So in triangle BCD, tan 60 will be opposite CD by BC. That is CD by BC will be equal to tan 60, value of tan 60 is root 3 or CD will be equal to root 3 BC. So in the equation 1, we got CD in terms of AC, and in the equation 2, we are getting CD in terms of BC. But CD being the same, you can equate the RHS of both the equations. So which means root 3 AC by 3 equal to root 3 BC. Right? So if you, let's just go one step back. So you got CD equal to root 3 AC by 3. And here you are getting CD equal to root 3 BC. So which means the RHS of this and RHS of this are equal because it is the same CD. So that is how we are getting root 3 AC by 3 equal to root 3 BC. Or AC will, you can cancel this root 3 and root 3. So AC will be equal to 3 BC. Am I right? So AB, and what is AC? AC is AB plus BC. So what is AC? AB plus BC. So next relationship is AB plus BC equal to AC, and we know BC is AB is 4000. Am I right? The distance between the two stations is 4000. So this becomes 4000 plus BC equal to AC, but we know AC is 3 BC, right? So substitute that here. So you will get 3 BC, right? Then what happens? So 3 BC, so BC goes to the other side, it becomes 2 BC. So 2 BC will be equal to 2000 or BC will be equal to 2000. Sorry, 2 BC will be equal to 4000 and BC is equal to 2000. Right? That's all. Once that is done, what are we asked to calculate? We are asked to calculate CD, and CD is root 3 BC. So CD is 2000 into root 3. That is 2000 into 1.732. So that is 3464 kilometers. You got it? So let me summarize. So draw the diagram. Get use tan 30 and get AC, a relationship between, or CD in terms of AC. Okay. Then similarly using this triangle tan 60, get CD in terms of BC. Equate that CD. So we see you are getting a relationship between CD and AC in the first equation, and you are getting a relationship between CD and BC in the second equation. You equate both the RHS, you will get a relationship between AC and BC. Next, you already have one more relationship, which is AB plus BC equal to AC, and we know AB is 4000. So use that and get one more relationship. Solve these two relationships or equations, you will be able to get BC. Once you get BC, you will be able to get CD using equation 2. Okay, so that is how this problem is to be solved. I hope I have made it clear. If not, please go through this video one more time. It will become clear. Thanks for watching this video.